Isothermal process. A process in which the temperature of the system is kept fixed throughout is called an isothermal process. The expansion of a gas in a metallic cylinder placed in a large reservoir of fixed temperature is an example of an isothermal process. For an isothermal process, the universal gas equation becomes PV equals to constant. That is, the pressure of a given mass of gas varies inversely with its volume. Work done in isothermal process. Suppose an ideal gas goes isothermally at temperature T from its initial state P1V1 to the final state P2V2 at any intermediate stage with pressure P and volume change from V to V plus delta V small. Delta W equals to P delta V. Taking delta V tends to 0, summing the quantity delta W over the entire process, we get W equals to integration of P multiplied by dV for interval V1 to V2. Using ideal gas equation, it becomes W equals to RT multiplied by integration of 1 by V dV for interval V1 to V2, which gives W equals to RT natural log of V1 by V2. For an ideal gas, internal energy depends on temperature. Thus, there is no change in the internal energy of system in isothermal process. Thus, using first law of thermodynamics, we have Q equals to W. Observations. First, for V2 greater than V1, W is greater than 0 and Q greater than 0. In an isothermal expansion, the gas absorbs heat and does work. Second, for V2 less than V1, W is less than 0 and Q is less than 0. That, in an isothermal compression, work is done on the gas by the environment and heat is released. Now let us see the graph between pressure and volume. The graph is a hyperbola as PV equals to constant.